Friends, in a huge forest, species have captured individual atoms and watched them merge. Okay, so it's quite an achievement. To understand how atoms unite to turn into molecules, we need to case them in action. But to do that, physicists must force atoms to pause long enough for the exchanges to be recorded. Yes, and that is no easy task. And one physicist from the University of Ottawa have only just recently achieved that. Until now, the best physicists could do to understand the finer points of various atomic interaction was to calculate correlation based on averages among a crowd that has been settled down to the point that they all share an identity. This crowdsourced version of atomics provides plenty of useful insights, but cannot capture details on the bump and granular collisions between separate particles that sense more scattering. Every collision reaction atoms getting out of your experiment. One way to analyze this encounter is to graph isolated atoms with the equivalent of a tiny pair of tweezers. Hold them still and record the sentence as they made. Fortunately, just a pair of tweezers exists, made from specially aligned polarized like this. Laser-based forceps laser-based forceps can act as an optical traps for tiny objects. Given short enough light waves, an experiment has a good chance of trapping something as tiny as an individual atom in its spins. Of course, first atoms need to be cooled down. Atoms need to be cooled down right down to make them easier to case, because atoms are very hot, and then separated into an empty space. Describing it this way makes it sound easy, but it is a process that requires the right technology and a lot of patience to achieve. Yes, you need a lot of patience to achieve anything great. So subscribe and follow me. Okay, to support me you should subscribe and follow me. Friends, okay, our methods involve individual trapping and cooling of three atoms to a temperature of about a millionth of a Kelvin. 3 atoms to a temperature of about a millionth of a Kelvin using highly focused laser beams in a hyper-evacuated chamber, that is vacuum, around the size of a toaster surface mechanisms. We solely combine a tray containing atoms to produce controlled interaction that we measure. Of the rubidium variety, which is bound to form molecules of dirubidium. But just 2 atoms are not enough to achieve this. Yes, 2 atoms alone cannot form a molecule. It takes at least 3 to do chemistry. You see, 2 atoms alone cannot form a molecule. It takes at least 3 to do chemistry. Yes, modeling how this takes place is a real challenge. Yes, it is clear that 2 atoms have to come close enough in such a way that they form a bond, while a third takes away a portion of that bonding energy to leave them connected. It is clear the 2 atoms have to come close enough. 2 atoms have to close enough in such a way that they can form a bond. Yes, while a third takes away a portion of that bonding energy. Yes, to leave them connected. Yeah. Working out the mechanism of how to mean to build signal nightmare to into the actions of any more can be nightmare. 3 body recombination between atoms should in theory cause the force out of the resonating here to study interaction between multiple. Using a special camera to magnify the changes, the team captured the moment the rubidium particles came close together, revealing the rate of loss wasn't anywhere near as common as expected. In effect, it also means the molecules were not coming together as quickly as existing models could explain. In effect, it also means the molecules were not coming together as quickly as existing models could explain. Something about the confinement of the atoms. It is unexpected. There is plenty of physics to be explored using this. There is plenty of physics. Our work is the first time it has been studied in nature. Several surprising results that were not expected from previous methods. That's software update is going on. What software update is? So it's nice to see. You see, atomic scale, and I'm thrilled. Our cell strives to pave the way for being able to build at a very small scale every person. So as one song is playing, this might have copyright issues. So I will end the video here. Well, it's a good news.